The last lecture, simplifications of inverse trigonometric functions. For example, if you have sine, we need cosine, or let's check that. Sine squared of sine inverse 2x. Sine squared of sine inverse 2x. If you have this problem, now we know that sine squared is exactly sine something squared is exactly sine that angle whole square. Okay, so that would be sine of sine inverse 2x whole square. Now we have this relation, sine of sine inverse. So these cancel each other. These two functions have effects that cancel each other. So it will be sine inverse. So that would be, after cancelling each other, the resultant would be 2x whole squared, which is 4x squared. Okay? But in this case, we had this special case when there is a sine outside and a sine inverse inside, with no separator between them. But if we have, for example, something like this, cosine of sine inverse x over 3, for example, if I have this cosine, now this cosine is different from that sine. If it was sine of sine inverse x over 3, it will be easy. Just this will cancel that and it will be x over 3. Okay? But now we have cosine of sine inverse x over 3. How would we treat that? How to deal with that? Now, simple steps. It's called triangular method, or method of the triangle. Simple steps. We take that inverse function and we call it some angle alpha. We have learned that every inverse trigonometric function is an angle. So this is an angle. We call it alpha. Alpha is sine inverse x over 3. Now take sine both sides, so that will be sine alpha is x over 3. In this case, we can make a triangle for that angle alpha. Now what is... أول مرة تحضري صح؟ طيب بصي عشان تبقي عارفة بس النظام، هو المحاضرة هنا بتبقى بالإنجليزي ماشي؟ فعشان في معانا ناس بالإنجليزي، فأنت لو حابة أنت الإنجليزي مش متوافقة معاه أو أحسن بالنسبة لك تسمعي بالعربي، ففي ميعاد المحاضرة الأربع الفترة الأولى اللي هي من 8:30 الصبح، فدي أنا بديها في نفس الدور ده بس الناحية التانية يوم الأربع الساعة 8:30 الصبح. أيوه تمام. فأنت لو أنت مش حابة الإنجليزي تعالي يوم الأربع الساعة 8:30 الصبح. أوكي؟ Okay, now we'll have this triangle with angle alpha. Now, the sine is x over 3. How do we depict that on the triangle? Do you remember? What is the sine? It is the opposite over the hypotenuse. We know the triangular, ratios or not? Sine and cosine and tan related to the adjacent. This is the adjacent and this is the opposite. And this is the hypotenuse. Okay, we know that the sine is the opposite over the hypotenuse. Okay, so we will just depict that, put that x here as the opposite and put the 3 as the hypotenuse. Now we complete the triangle. How to complete the triangle? How to find that missing side? Yes, Pythagoras theorem. أو نظرية فيثاغورس اللي هي إيه؟ We find it by this. Can you tell me? This will be 9 minus x squared. The squaring of the hypotenuse minus the squaring of any of the two other sides. The hypotenuse is the largest side in any triangle. The hypotenuse is the largest side in any right triangle. Okay? So it will be, now we have this, the triangle is complete with me now. Now what do I want to compute? Remember, what I want to compute is cosine of sine inverse x over 3. but this is called alpha. So what I need to compute is cosine of alpha. From that triangle, I can compute cosine alpha. What is cosine of the angle? It is adjacent over the hypotenuse. Adjacent is, now in this case the adjacent is the root. That would be root 9 minus x squared over the hypotenuse, which is 3. So that is exactly the simplification of this expression. This is exactly the simplification of this expression. Okay? Now if you have, for example, this expression, sine of 2 sine inverse x over 3. Sine of 2 sine inverse x over 3. Now you may say that we have sine and sine inverse, they may cancel each other, so that will be 2x over 3. Is that correct? No. I can't ever cancel the sine and sine inverse whenever there is a separator between them. Okay, so I can't cancel these two by each other. Okay, so this is incorrect. This is incorrect. So what or how would I deal with this? Yes, I know that sine double the sine double of the angle. What's the sine of a double of angle? It will be 2 sine of that angle times the cosine of that angle. Now let's treat each of them separately. This one, now this one is sine of sine inverse. So they can cancel each other. So that will be 2 times x over 3. What about this? This is exactly the last problem. The previous problem was just exactly that expression, which is the root 9 minus x squared, root 9 minus x squared over 3. I solved it by the same steps that I've done in the last problem. Okay? Now, what if I have this expression? What if I have this cosec inverse of sine x? This one is easy. I can solve it with a triangle. Any expressions whenever the I meant that to be that would be sine inverse in this side. Cosec of sine inverse x. Cosec of sine inverse x. Whenever the inverse function is inside, it is solvable by the triangle. Whenever the inverse function is inside, it is solvable by the triangle. Okay? But in this case, it is very easy. It doesn't need even a triangle. Why? Because what is the cosec? It is the reciprocal of the sine. So this is exactly 1 over sine of sine inverse x. So the sine will cancel the sine inverse and it will remain, only the x will remain in the denominator. Okay? So that is easy. What if I made it like this? Sine of cosec inverse x. Sine of cosec inverse x. How would we solve this, or how would we simplify this? I can solve it with a triangle. I can take this to be alpha and make a triangle, then I find the sine of the alpha from the triangle. This is the general method. But this is easier than making a triangle for it. We can find it very easy. How? What is the sine related to the cosec inverse? It is 1 over cosec, so that is exactly 1 over cosec of cosec inverse x. So this will cancel this and the remaining will be also 1 over x. Okay, so these are problems that doesn't need any triangle in it. What about sine inverse of 2 sine 4x cosine 4x? Sine inverse 2 sine 4x cosine 4x. Now, whenever I have the inverse outside, the inverse function in outside, I must make this expression in this form, sine of something. Sine of something. Can I put this expression in a sine of something? Yes, it is Yes, sine double angle. This is exactly the expression of sine double angle. So that will be 2. This is sine of double the angle. Sine double the angle, which is 8x. Now in this case, this will cancel this, and the result will be 8x. Okay? What about this problem? If I say cosine inverse of 1 minus 2 sine squared x. Whenever I have the inverse function outside, not inside, any expression that has the inverse inside, it is solvable by triangle, or any other expression that is easy, as we have with simple cancellation, as we have seen. Okay, but in this case, we have the inverse function outside. So we need to put, or we must put, to make any simplification, we must put the inside function as a cosine of something. To make a cancellation, cosine inverse with the cosine. Could I make this cancellation? Could I make this, what is inside, could I make it, or could I write it as 1 minus 2 sine squared? Yes. How? We know that this is exactly cosine double the angle. We have 3 expressions for cosine double the angle. What is cosine double the angle? It is cosine squared angle minus sine squared the angle. Also we have 2 cosine squared the angle minus 1. Also we have 1 minus 2 sine squared double the minus 2 cosine 2 sine squared the angle. We have 3 expressions for cosine double the angle. Is this one of them? Yes. This is exactly which one? The third one, yes. Third one. So this is exactly cosine double the angle. So that will be cosine inverse of cosine 2x. Now we may cancel this by this, and it will be 2x. What if I write the expression like this? If I write a cosine inverse of 2 sine squared x minus 1. Now that will be, what would that be? 2 sine squared minus 1. That is minus the cosine of double angle. It is just that expression, but with an opposite sign. Yes, with an opposite sign. So that will be cosine inverse of minus cosine of double the angle. I still can't cancel the cosine inverse with the cosine, because I have a separator here, which is the negative sign. But I have learned a rule, which is cosine negative of something is, do you remember the rule? Yes, pi minus cosine inverse that angle. Pi minus cosine inverse that angle. So I will say here that this is just pi minus cosine inverse of cosine 2x. Now this cosine inverse could cancel the cosine, and the result will be pi minus 2x. So in this case, the result will be cosine minus 2x. What about this expression? Sine inverse of cosine x. Also we have here the inverse outside, not inside. So we just need to put this cosine as sine of something. How would we do that? Yes, we have some relations of the complement of the angle. We know that cosine of x is exactly the sine of pi over 2 minus x. This is called the complement of the angle. And this is exactly what this is The is abbreviation of the complement of the angle. What is the complement of the angle? It is the angle which, if I have this is angle alpha, so this is the complement of the angle, which completes the angle to be 90 degrees. Okay? So if I say, for example, sine of x is exactly the cosine, the complement of, or the cosine of pi over 2 minus x. Also, if I have cotan of x is exactly the tan of, I remove the to be pi over 2 minus x. Also, if I have sec x, it is exactly cosec of pi over 2 minus x. Okay? So I can, if I have a co in this side, I can remove the co but put the angle as pi over 2 minus x, and so on. If I don't have a co, I can put a co but make the angle pi over 2 minus x. Okay? So in this case, I need this to be sine, not cosine. I need to make it a sine. So I can say that this is sine inverse of sine of what? Of pi over 2 minus x. Now in this case, the sine inverse will cancel the sine and the result will be pi over 2 minus x. Okay? Okay. Also, we will learn the derivatives of inverse trigonometric functions. Derivatives of inverse trigonometric functions. There is a table, sine inverse of something. Its derivative is 1 over root 1 minus what is inside all squared, times, by the chain rule, times the derivative of that something. If I have tan inverse, that will be 1 over 1 plus all squared like this. If I have sec inverse, it will be 1 over that thing, root that thing squared minus 1, also times the derivative of that thing. Okay, so this is the three rules of the derivatives of inverse functions. Now you can tell me, what about the cosine inverse, what about the cotan inverse, what about the cosec inverse? Yes, each of those. Now remember, each of these doesn't have a co. Each of these doesn't have a co. If I make the relation with cosine inverse, so the inverse will be just exactly like that one, but with an inverse, but with a negative sign. Tan inverse, what the derivative of cotan inverse? The derivative of cotan inverse will be just minus 1 over 1 plus that squared. What the derivative of cosec inverse? It will just be the negative of that expression. Okay, so let's apply these rules. If I have, for example, y is equal to x tan inverse root x, I need to find the derivative. I need to find y dash. So what is y dash in this case? The first derivative of the second. What is the derivative of the second? Now I have the tan inverse. What is the derivative of tan inverse? It is 1 over 1 plus what is inside squared. What is inside squared, which is root x all squared. I have finished the tan inverse. Now I go inside the tan inverse. What is inside the tan inverse? Root. What is the derivative of the root? It is 1 over 2 root x. Now I interchange plus the derivative of the first, which is 1, times the second as it is, which is like this. Okay, any problems with that? Let's check another problem. If I have, for example, y is equal to ln sine inverse 2x. At first, we have learned that whenever I need the derivative of ln, I use the properties of the ln to simplify the expression. Can I take this negative 1 and take it beside the line, the ln? No, this is not a power. We have learned that sine inverse, this is not a power to apply this rule. It is just a symbol for the inverse operation or the inverse function. It is not a power. Okay? So I cannot take this negative 1 and take it beside and apply the rule of the ln. I will just leave it as it is. Now I apply the derivative. I need to find the derivative of this expression. Y dash will be equal to the first function that I will encounter is the ln. What is the derivative of the ln? 1 over what is inside. 1 over what is inside. This is the derivative of ln. Now I finished the ln. Now I go inside the ln. What is the first function that I will encounter? It is the sine inverse. What is the derivative of sine inverse? It is 1 over the root of 1 minus what is inside squared. So it will be 2x all squared. You need to remember the rules. You need to memorize the rules of the table. So I have finished the sine inverse. Now I go inside the sine inverse, and I will find a 2x. What is the derivative of 2x? It is just 2. It is just 2. So this is the derivative of this expression. If I have this expression and it tells me find the derivative of that, or find y dash, tan inverse of xy is equal to 1 plus x squared y. What is y dash? This is implicit differentiation. Have you noticed that this is implicit? Why it is because it is an implicit expression. I don't have the y by itself in one side. All these expressions were these were explicit expressions. So this is explicit differentiation. But this one is implicit differentiation because I have the x, y are all together on both sides. How do I find the derivative in this case? By implicit differentiation. I just make the derivative normally, but just put in mind that y has x inside it. That y is a function of x. So whenever, if I want to make the derivative of that side, what is the derivative of tan inverse? It is 1 over 1 plus what is inside squared. What is inside squared? I finished the tan inverse. Now I go inside the tan inverse, I will find this is a product. This is a product in this case. Why? Because there is x inside the y. So we have a product rule. I will make a bracket for the product rule because I have two terms. The first times the derivative of the second. What is the derivative of the second in this case? It is y dash plus the derivative of the first, which is 1, times the second as it is, which is 1. This is equal to 1. This is 0 plus what is the derivative of? Yes, I have here another product which will be the first as it is times the derivative of the second plus the derivative of the first times the second as it is. Now I try to find the y dash only in one side. I need to find it all in one. I will find the expression, all the terms that have y dash. I can make it more proficiently all at once like this. I will just look at this y, these two terms. I will put it all in one side. I will just take the coefficient of the y dash. In this side, I will have the coefficient y dash to be x over 1 plus xy all squared. Remember, you need to put this in mind. Don't miss this expression. This is multiplied by the two terms. So don't miss it. Some students just take that x and put it as the coefficient of y dash. No, we have this also. This is multiplied by the two expressions. Also, we have this term, which I take it to the other side. So that will be minus x squared. Now, for the other side, I will just put the expression. I just remove any term with the y dash, and any other expression, I'll take it to the other side. In this case, I'll take it to the other side. So I'll have this term, which is y over 1 plus xy all squared. Which with a negative sign. I've taken it to the other side. So I change the sign to be negative plus 2xy like this. There is just one remaining step, which will be y dash will be equal to that green expression over the red expression. Okay? I can make a common denominator if I need to simplify it more furthermore. Okay? But I can leave it as it is like this. Okay? So that part was from the last lecture. Now we start with today's lecture. We will study a new type of functions which is called hyperbolic functions. It is called hyperbolic functions. Now just remember that do you remember even function plus even function is equal to an even function? Odd function plus odd function is odd function. What about even function plus odd function? It is general function. Yes, correct. Now this last expression can be read by two ways. That any general function can be decomposed to two components. Component even function and component as an odd function. Any general function that has a domain which has a symmetric domain, we call it which has a symmetric domain. What is a symmetric domain? A symmetric domain is from negative a to a. It has a domain which is from a symmetric domain, negative on both sides of the zero or the y-axis. Whenever I have a general function with a symmetric domain, so it can be decomposed to two components, an even function plus an odd function. A very important function that we have studied is the exponential function, which is e power x. But do you remember that e power x is a general function? Remember the graph of e power x is just like this. So this is a general function. But because this exponential is very important function and it is general, so we need to find two components of it. A component which is even and a component which is odd. The two components are exactly what is called the hyperbolic functions. We'll say that e power x is cosine x plus sine x. What is sine and cosine? This is cosine, but plus the word hyperbolic. Cosine plus hyperbolic. So we're just taking the h, we're just taking that h and put it with the cosine, so it is called cosine. Cosine. It is pronounced like this, cosine. And this is pronounced as shine. Or in some universities they just pronounce it as sine. So it may be pronounced as shine or it may be pronounced as sine. Okay? Or some pronounce it as cosine h and sine h. So they just put a cosine plus h. Okay? So this is the even component and this is the odd component. What are these two components? They are exactly like this. Cosine x is e power x plus e minus x over 2. And the sine x is e power x minus e power minus x over 2. If you check this expression, you will find it will be an odd function, an even function. If you take every x to put minus x, it will be an even function. So if you put like this, f of minus x will be just, or cosine negative x is exactly cosine x. For this, you will find that it is an odd function. So sine of negative x, it will be exactly negative sine of x. Okay? So these two expressions, this expression is even and this expression is odd. Okay? Now we need to study these two functions, or we will build a structure just like the structure of the cosine and sine and the trigonometric functions. So we have learned the cosine, which is e power x plus e minus x over 2, and we have learned the sine, which is e power x minus e minus x over 2. What about the tangent x? What is tangent x? It is exactly sine x over cosine x. What is cotangent x? It is cosine x over sine x. What is sec x? Sec x is exactly 1 over the cosine of x. What is cosec x? It is 1 over sine of x. Okay? So these we have just six ratios as we had in the trigonometric functions. Okay? Now we just need to graph basically these two or these three functions. The cosine is like this. It is an even function like this. It is an even function like this. Now, just notice what is the domain? It is R. It It is all R. Okay? It is just like, now this is 1, because cosine 0 is equal to 1. Just like the cosine. Just like the cosine. Cosine 0 is equal to 1. Also we have here cosine 0 is equal to 1. Okay? But in this case the range is yes, the range will be, it is from 1 to infinity. The range is from 1 to infinity. Now remember that cosine is always a big number. It is a big number. So, or cosine is always, cosine of something is always greater than or equal to 1. It is a big number. Always, not just a positive number, it is a number that is greater than 1. It is not just a positive number, it is also greater than 1. I cannot have a cosine equal to negative, for example, a cosine equal to a fraction, half. No, I don't have any of these. What about it is even? Also it is even. We have learned that. It is obvious here that it is even. And it is must like the expression of x squared plus 1. The graph is must like the graph of x squared plus 1. Okay? What about the shine? The shine is like this. The shine x is like this. It is much like, what power function have you studied is much like this? Do you remember? Yes, it is just like x cubed. It is just like x cubed. So this is shine x. And it is an odd function. It is an odd function. What about the domain? We have here the domain and the range are equal to R. The domain and range here are equal to R. What about the tanh? Now the tanh has a special property that for infinity it will approach 1, and for negative infinity it will approach negative 1. So the graph of tanh is like this. We have a horizontal asymptote. We have a horizontal asymptote. We have a horizontal asymptote for a horizontal asymptote for the positive side. The positive side, we learned that tanh infinity is just 1, and tanh of negative infinity is just negative 1. Also, it is obvious that the domain is from the graph. What is the domain in this case? The domain is R. What is about the range? Yes, from negative 1 to 1, but in this case it is open. It is open from negative 1 to 1. It is an open interval from negative 1 to 1. بس عشان برضه انتوا عارفين النظام، انتوا عرب صح؟ ايه؟ ايوه العربي يوم الاربعاء على الناحيه الثانيه. خلاص عارفين النظام يعني. تمام حلو. تمام انا لازم ابلغ عشان ايه كله يبقى عشان محدش يزعل. اوكي. Okay, why are they called cosine and sine? Why haven't we just named it with some other name? Because they have just relations too similar to or much have many analogies with the trigonometric identities. For example, we know for trigonometric identities, we know that cosine squared plus sine squared is equal to 1. Also we have 1 plus tan squared is equal to sec squared. Also we have 1 plus cotan squared is equal to cosec squared. Yes, I have just similar expressions but for the hyperbolic side, but with a minor modification. We will have a modification in sign of some terms. A general rule, whenever you find in this side, whenever you find a term which is a multiplication of two signs or a multiplication of two tans, whenever you find a term which is a multiplication of two signs or a multiplication of two tans, whenever you find this term, just change its sign. Just change its sign. So, what about this expression? Cosine squared plus sine squared. Do I have two sines or two tans that are multiplied by each other? Yes, I have this term. This term is exactly two sines multiplied by each other. So I'll just change the sign of this term. So the new rule for hyperbolic, or the analog rule for this rule, which will just be cosine squared, but minus sine squared. But minus sine squared of some. Now this, what is inside the sine and cosine, it is not an angle. It is not explicitly an angle. But we may call it an angle just to make it easier for ourselves. But it is not an angle. We may call it a hyperbolic angle, but it is not an angle. Just remember, it is not an angle. Why? Because this is just an input of an exponential, or an argument of the exponential. What we put inside an exponential is not an angle. Okay? So these are not angles, but we may take it or call it an angle, but knowing that it is not the correct expression for it. Okay, now let's make a new expression for this one. Do I have two tans or two sines multiplied by each other? Yes. This one, this term. What about this? No, this is two cosines multiplied by each other, not two sines. So I will not change I will not show the sign of this one. I'll just sign that will be 1 minus tan squared x, or tan squared something, equal to sec squared of that thing. Now for that third rule, what about this one? Do I have two tans multiplied or two sines multiplied by each other? Yes, we have two terms in this case. What are the terms? Yes, this term has two tans multiplied by each other. A cotan is just 1 over tan. So cotan squared. So I will change the sign of this term. That will be 1 minus cotan squared something equal to minus cosec squared. Why did I change the sign of this term? Why did I change it? Because it is a reciprocal of sine. These are two sines multiplied by each other, but they are in the denominator. Okay, they are just in the denominator. Okay, so these are three rules which are analogous to these other rules in trigonometry. Just apply this for any trigonometric rule that you have learned. For example, you know the rule that says cosine 2x is equal to cosine squared minus sine squared, or the one that is saying 1 minus 2 sine squared, or the one that is saying 2 cosine squared minus 1. Let's write the analogous expressions. Now we have cosine 2x will be, this will not change its sign, so it will be cosine squared x, but this one will change its sign, so it will be plus sine squared x. Now it is plus. Now it is plus. What about this? Yes, it will change. It will be 1 plus 2 sine squared x. What about this expression? No. In this expression, it doesn't have any two signs multiplied by each other, or neither it has two signs multiplied by each other. So it will just be 2 cosine squared minus 1. What about sine double angle? Sine double the angle. It is 2 sine cosine. Do I have here any two sines or tans multiplied by each other? No. So it will just be the rule as it is. It will be sine 2x will be 2 sine x cosine x. All the trigonometric rules that you have learned, for example, cosine a plus b. Do you remember what is the rule of cosine a plus b? It is cosine a cosine b, the opposite sign, which is minus sine a sine b. I need to write the analogous expression, but for the hyperbolic function. It will be cosine of a plus b. Now, do you have here two sines or two tans multiplied by each other? No, it is just cosine. So that will be cosine a cosine b. What about this term? Yes, I will change it. So that will be plus sine A, sine B. Okay? So all of the rules that we have learned in trigonometric functions, we will have just analogous expressions for them. Okay? Actually, for the simplification, we will have two methods in hyperbolic. We have learned in trigonometric, we have learned simplifications by the triangle. We have also an analogous triangle which we will call a fake triangle. But let's check this type of problem. If I have this problem, tang of 2 ln x, and he tells me simplify tang 2 ln x. Now, for this expression, whenever I have a ln or a logarithmic function inside a hyperbolic function, we use the definition of the hyperbolic function. So tang 2 ln x, we just write it like this. It is sine 2 ln x over cosine 2 ln x, which is, what is the sine? It is e. This is the definition. Why do I use it? Because I will write the tang in terms of exponentials, and when I put exponentials and I have ln, the simplifications will be much easier. Okay, so whenever I have a ln inside the hyperbolic function, I put the hyperbolic function in the form of this definition. Okay, so that will be sine, it will be e power 2 ln x minus e minus 2 ln x over 2. And also you have here e power 2 ln x plus e power minus 2 ln x, but over 2. Now this 2 will cancel with this 2. We will have this expression e power 2 ln x minus e power minus 2 ln x over e power 2 ln x plus e minus 2 ln x. Now remember that e power ln something is, they cancel each other. So because they are inverse functions to each other. So in this case, but this must be a direct operation. E directly operating on the ln. I don't have a separator. But whenever I have a separator, I can't apply this rule. So what would I do in this expression? I have here a problem. The e cannot cancel the ln. The e cannot cancel ln. Why? Because I have a separator here which is 2. A separator here which is 2. Can I get rid of this separator? 2? Do you remember the properties of ln? I can take that 2 to be, yes, take it inside. And I take this minus 2 to take it like this, and this 2 like this, and this minus. So the expression will just be like this: e power ln x squared minus e power ln x power negative 2 over e power ln x squared plus e power ln x power negative 2. So that will be, this will cancel with this will cancel with this will cancel with this. So I will have x squared. I will have x squared minus x power negative 2 over x squared plus x power negative 2. I may simplify it furthermore by, I don't like negative powers, because negative powers mean that there is a denominator inside and a numerator. This expression is just like this. I don't like expressions like these. So I will just get rid of this denominator here by multiplying by x squared in the numerator and denominator. So it will just be x power 4 minus 1, x power 4 plus 1. And this is the simplification of the problem. Okay? Have you understood what I've what I've explained here? Any problems?
Can I take a picture?
Hmm? What about this? Let's check. Make this simplification. Cosine, cosesh. If I have cosesh, ln x plus cotange ln x. I need to make a simplification. Also, we have learned here what is cosine, cosesh. It is the reciprocal of sine. So this is 1 over sine ln x plus cosine cotange, which is cosine ln x over sine ln x. Okay, so that will be, these are the same denominator, so that will be sine ln x 1 plus cosine ln x. Now I have ln x inside hyperbolic functions, so I will just put the cosine and sine in its definition form, which is with respect to e, which is in terms of e. So that will be 1 plus e power 2 ln x plus e minus 2 ln x over 2, and that will be e power 2 ln x minus e minus 2 ln x over 2. Do you remember how to cancel the e with the ln? I take these above like this. So it will be like this. It will be 1 plus, it will be x squared plus x power negative 2 over 2 over x squared minus x minus 2 over 2. I can multiply by 2 above like this to be 2 plus x squared plus x power negative 2 over x squared minus x power negative 2. I can also multiply by x squared, so it will be 2x squared. The result will be 2x squared plus x power 4 plus 1 over x power 4 plus minus 1. It will be just like this. So this is the simplification of this problem. Okay. Also, based on these simplifications, we may ask you for solving a question like this. So if I have tangent of 2 ln x equal to what? And I tell you solve this equation. Solve equation. So what is meant by solving equation? To find x that satisfies this equation. Find x that satisfies this equation. Now I have a ln inside the tangent. So I just use the definition of tangent, which will be e power 2 ln x, a sine divided by a cosine. So that will be minus e minus 2 ln x over e power 2 ln x plus e minus 2 ln x. I have divided by 2 both in the numerator and denominator, but they cancel each other, so it will be settled like this, and that will be half. Also I apply these like this, so it will be x squared minus x power negative 2 over x squared plus x power negative 2 equal to half. I need to solve for x. Maybe it's better to just multiply by x squared to get rid of this negative power. We don't like that negative, so it will be x power 4 minus 1, x power 4 plus 1 equal to half. Now I take the cross rule, which says that will be 2x power 4 minus 2 equal to x power 4 plus 1. I need solve for x, so that will be x power 4 is equal to 3, which is x will be plus or minus the 4th root of 3. X will be plus or minus, because this is an even root. It will be plus or minus the 4th root. But remember, whenever I solve an equation, I must check the solutions. Do they satisfy the main equation or not? Do they satisfy the main equation or not? Why? Because I may, when I make the cancellations in my steps, I may modify the domain. So the solutions may be, some of the solutions may be rejected. What do you think about these two solutions? Are they allowed for as solutions for this equation or not? Are they accepted? Both are accepted. Can I put a negative value inside the len? Can I put a negative value inside the len? No, I've learned that the len, what is inside the len must be greater than 0. It's just like the root, but without the equal sign. Okay, so I cannot put a negative value inside the len. So that's why the negative is rejected. The negative, only the positive is accepted. Okay, only the positive here is accepted. Okay, so the solution set is just the fourth root of 3. It is just the fourth root of 3. If I have this equation, for example, if I have solved equation, cosine len x equal to sine len x over 2 plus 7 over 4. Also we have simplifications in this case. A len inside a cosine, a len inside or len inside hyperbolic functions. How do you deal with that? By the definition. E power len x plus e minus len x over 2 equal to e power len x over 2 minus e minus len x over 2 plus 7 over 4. Now we'll just, that negative sign, we'll take it inside the len like this. So it will just be x plus x power negative 1 all over 2 equal to x over 2 minus x power negative 1, it's all x over 2 power negative 1. So it is so it is 2 over x over 2 plus 7 over 4. To get rid of these denominators 2, 2 and 4, I will multiply the whole equations by 4. I will multiply the whole equation by 4. So it will be 2x plus 2x power negative 1 equal to by 4. So it will be 2 times 2 again, it will be x minus, so that will be 8 over x plus 7. And that will be 1 over x. I will also multiply the whole equation by x. So to get rid of that x in the denominator, so it will be 2x squared plus 2 equal to x squared minus 8 plus 7x. Now this is just a quadratic equation. I will just solve this quadratic equation. It will be x squared minus 7x and that will be plus 10. This can be factorized. x 5 and 2, which multiply by each other to get 10, and it's that will be, yes, it will be negative and negative. So we have two solutions, x equal to 2 and x equal to 5. Just we need to check, do these two solutions satisfy the domain of the equation? Yes. So we don't have any restrictions. We don't have a negative value, for example, that is forbidden to be inside the len. No, we don't have this case. Okay. Also, we can simplify based on some triangle, just like trigonometric functions. We use a triangle in trigonometric functions. We can also use, it is called the fake triangle in hyperbolic functions. For example, if I have sin x equal to half or negative half, sin x equal to negative half, find cosine x and tangent x. Find cosine x and tangent x. How would we find this? We just make a triangle like this, but I will call it a fake triangle, and I highlight that adjacent like this, just to make it more obvious that this is not the ordinary triangle that we are dealing with in this case. Okay, I will just depict that on the triangle. Sine, what is sine? It is opposite over hypotenuse. Okay, opposite over the hypotenuse. So I'll just make it like this: -1 and 2. -1 and 2. Now, how to find that side? Now remember, this is not an ordinary triangle. It is a fake triangle. It tells me that deal with this triangle as if the adjacent was the largest side. As if it was like you used the same rule of the hypotenuse before. So in this case, that will be the square root of 2 squared plus the 1 squared. It is fake. It is not correct, but it will just give me the correct answer for the cosine and tangent. So that will be the root of 4 plus 1. It will just be root 5. Now I need to find the cosine. What is the cosine in this case? Yes, it will be root 5 over 2. Now this is greater than 1. Do you remember? I've told you that the cosine is always a number that is greater than 1. It is a number that's always greater than 1. Also, we have the sine. We need to find the tangent. What is the tangent? And whenever I have a sine with a negative, with some negative, I put the negative with the opposite. It will go over the other roots. Okay, tangent. What is the tangent in this case? It will just be -1 over root 5. Okay, I can find any other ratios. Okay, it is obvious how to make a fake triangle. Okay, let's check this one. If I tell you that I have tangent x is equal to -half, and I need to find the cosine x and the sine x. In this case, let's make the fake triangle of this case. Let's make the fake triangle. If I have a negative sign, just put it with the opposite. If I have a negative sign, just put it with the opposite. Okay, so I just put this to be -1. Okay, now what about the 2? I'll just put it with the hypotenuse. It will be like this. No, tangent. This is tangent will be here. Tangent will be here. Now I need to complete the triangle. How would I complete it in this case? Now remember, deal with this side as you have dealt with it as if it was a hypotenuse. As if it was a hypotenuse. So in this case, that will be 4, but -1 squared. So that will be root of 3. In a fake triangle, this is always the largest side. In a fake triangle, this is always the largest side. Okay? So in this case, if I need to find the cosine, what is the cosine in this case? It will just be 2 over root 3. What is the sine? In this case, it will just be -1 over root 3. Very easy. Okay? So whenever you have depicted the fake triangle correctly, it will you find the solution very easy. Now, if I have this case, cosine x equal to 3 over 2. Now find 3 over 2. Find sine x and tan x. So this will be a fake triangle. 3 over 2, it will be 3 over 2, which is this. Now how would I complete the triangle? Yes, treat the adjacent as if it was the largest side. It is, yes, it is 9 minus 4. It will be just be right root 5. Okay? Just be root 5. So what is sine? The sine will be root 5 over 2, and the tan should be root 5 over 3. But there is just a note here. This is not a complete answer. Why? Because if I tell you that cosine x is equal to some number, it is like this. 3 over 2. 3 over 2 here. If I tell you that cosine x is equal to 3 over 2, what is x here? Does it have one value or more than one value? Yes, I have, as if I have two angles that have its cosine equal to 3 over 2. I have this one and the other one in the negative side, which is exactly like it. Because this cosine is an even function. The cosine is an even function. So, whenever I have cosine like this, it will be, we'll just put that to be plus or minus like this. So that will be plus or minus, plus or minus. This happens only in the case of cosine. In the cosine, it will be when that side, I'll just put it plus or minus like this. But this is different from saying that x is equal to cosine inverse of 3 over 2. Just like the square root. The square root, if I tell you solve this equation, how many values do I have for x in this case? I have 2 values. Yes, 2 values. But if I tell you what is the root 4, root 4 has one, yes, one, just exactly one value. This is exactly the same case here. When I tell you that cosine x is 3 over 2, we have x here has 2 values. But when I tell you that x is equal to cosine inverse 3 over 2, it is just x has one value. Because an inverse function, it is a function, it has only one value. Okay? So if I say this, so x will be positive in this case, and I'll just put it positive, root over 5. I just put the plus or minus only in the case, when I have a cosine. Not in any of these other functions. Okay? Now, if I have, for example, I need to make this simplification. If I have cosine, what is cosine of sine inverse 3x? What is cosine of sine inverse 3x? I just deal with it as if I have made in the trigonometry. How would I treat this expression? I just take this and call it alpha. So I have alpha is equal to sine inverse 3x. And this means that sine alpha is equal to 3x. When I make a fake triangle for that alpha, this is a fake triangle because it's this sine. If I have this, it will be, this is over 1, it will be 3x over 1 like this. Can I complete the triangle? Yes. How would you complete it?
3 square, 3x.
3x all squared.
Plus 1 squared.
Plus 1 squared. Yes, exactly. Because I treat the adjacent as if it was the largest side of the triangle. Okay, correct? That would be root 9x squared plus 1. Exactly. So, I have the complete fake triangle for this expression. I need just cosine alpha. What is cosine alpha from this triangle? It will just be the root 9x squared plus 1 over the 1. Yes, exactly. Okay, so I've learned how to make simplifications just like the trigonometric functions, but with the exception of using fake triangle instead of the ordinary triangle. What about the inverse hyperbolic functions? Inverse hyperbolic functions. Inverse hyperbolic functions are much easier than inverse trigonometric functions. Why? Because we have the sine, the sine is a one-to-one function. Sine is just a one-to-one function. Do you remember in trigonometric function the sine was not one-to-one, and so we needed to restrict the domain. Do you remember? We needed to restrict the domain in order to have an inverse for the sine. But now we have for the sine, for example, for the sine x, it is just one-to-one. So when you make the inverse, it will just be, it's just called sine inverse x. Sine inverse x, it is just the reflection about the y equals x, a reflection like this. And we have here the domain and range will be equal to r, even for the f or the f inverse. For the tangent is like this. If you remember, the graph of the tangent is like this. And a mean property of tangent, the tangent infinity, when you go to infinity, the result is 1. And when you go to negative infinity, it will be, the result will be negative 1. We have horizontal asymptotes for the tangent. So when you make the inverse of this, it will just be as if you take it, because you interchange the x and y, so it will be like this. We have here, instead of 1 and negative 1 on the y side, it will be on the x side, like this, and it will be like this. Just like the graph of tan, the tan x, not tan, the tan, but tan restricted. It's just like the graph of the restricted tan. Okay, so it will be like this. Now we have here the domain. What is the domain of the tangent inverse? This is called tangent inverse. Tangent inverse, its domain is open from -1 to 1. So whenever I have a tangent inverse of something, I take that thing and put it inside an inequality to find the domain. And put it inside an inequality to find the domain. What about the range? The range is obvious, it is just R. These are just two expressions that are the opposite of in this case. In this case, the tangent by itself, the range was R. The range was from -1 to 1. The range was from -1 to 1, but the domain was R. So I just swapped the two like this. Okay, so these two functions are just 1 to 1, so they are very easy. Just 1 to 1 functions, so they are very easy. What about the cosine? Yes, the cosine has a different, it has a problem. Why it has a problem? A cosine by itself doesn't have an inverse. Why? Why does a cosine by itself doesn't have an inverse? Because it is not 1 to 1. The cosine is not 1 to 1. So we need to restrict the domain. What do you expect? What do you expect? How would we restrict the domain? We just take just as we have dealt with the x squared. Do you remember? I told you that this is just like the x squared plus 1. So just as we have dealt in the x squared, I'll just take the positive side. I'll just take this side. I'll just take this side. Okay, so I'll just take the restricted cosine, which is x greater than or equal to 0. Restricted cosine is x is greater than. So what is cosine inverse? The cosine inverse will be like this. Cosine inverse will just be like this. Cosine inverse will just be like this, as if you had a reflection about the y equals x. Okay, now the domain, the range is what about the domain? Yes, the domain will be from 1 to infinity, which is exactly the same range of the cosine, which will be from 1 to infinity, and the range of this would be from 0 to infinity. That is exactly the domain, the restricted domain, which will be 0 to infinity. The restricted domain of cosine is exactly the range, of the inverse. Is exactly the range of the inverse, and this is obvious from the graph of the function. Obvious from the graph of the function, as you have seen like this. Okay. So let's check this. I will use the inverse trigonometric inverse hyperbolic function to solve some equations like this. Maybe not. If I have 3 sine x, if I have this equation, if I have an equation like this, sine x equal to some number alpha, what is the solution? It will just have one solution, which is sine inverse alpha, because these are one-to-one functions. Also for the tanh, if I have tanh x equal to some number alpha, what is the solution of this equation? It will just be tanh inverse alpha. But in the case of cosine, no, we have a different case here. If I have cosine x equal to some number alpha, what will be the x? The x will have 2 values. Now remember, here we are solving an equation, not finding the inverse. The 2 solutions will just be in terms of the inverse. So it will be plus or minus the cosine inverse of alpha. Now remember, this case is just different. The cosine is different from the other 2 because the cosine is not one-to-one function. So if I have some number alpha and I need to find the cosine inverse is only one case that will have one solution, which is if I told you solve this equation, cosine x is equal to 1. So that will have only one solution, which is 0, because I don't have plus or minus 0. Plus or minus 0 is just a 0. Okay? What if I have an equation like this? Solve this equation. 3 sine x plus cosine x equal to 0. 3 sine x plus cosine x equal to 0. Now, if I can, or if I could make the equation in terms of only one hyperbolic function, all to be sine or all to be cosine. If I could make it like this, it is better. But if I couldn't, just like the case I have here, I will just use the definition. So in this case, I will write it like this: e power x plus e minus x over 2 plus e power x plus e minus x over 2 equal to 0. I will multiply the whole equation by 2, so that will be 3 e power x minus e minus x plus e power x plus e minus x equals 0. I will just write it at 3 e power x minus 3 e minus x plus e power x plus e minus x equal to 0. I will just take these 2 to be 4 e power x, and these 2 will be minus 2 e minus x equal to 0. Still, I can't solve this. I will just multiply by e power x to get rid of that negative power, because this e power negative s is just exactly 1 over e power x. I multiply by it, so that will be 4 e power 2x. What is e power x all squared? It is just e power 2x. Or I may write it like this. To be minus 2 equal to 0, and so that will be 4 e power 2x equal to 2. That will be 2, so e power 2x will be equal to 1 over 2, and that means that 2x is just exactly ln. I get rid of this e, I take ln both sides. So that will be 2x. If I say here ln, the ln will cancel the e, and I have 2x remaining, and it will be ln half, like this, and the x will be half, ln half, which should be the solution. I just make a quick check if any of this contradicts any of the domain of the equation. No, there is no contradiction in this case, so this is the solution. Now, if I have this expression, okay, for just this case, if I have this side to be 0, I have a much simpler solution than this one. What would it be if I have this side to be 0? I've just solved it for you for any number here. But if I had this to be 0, I can just make it like this. I take this to the other side. 3 sine x equal to minus cosine x. And I divide by the cosine, so it will be 3 tangent x equal to -1, which is tangent x equal to -1/3. Now, I have managed here to make the whole equation in terms of just 1. Do you remember? I told you if I can make the whole equation in terms of just one hyperbolic function, it will be much easier. And this is what the case in if I had this side to be 0. If I had this side to be 0, I can make it. I can take one of the terms to the other side and divide by it. It would be tangent. Tangent should be equal. Tangent x would be equal to -1/3. So what is x in this side? It's just tangent inverse of -1/3. I can take the negative outside, so it is negative tangent inverse 1/3, and I have solved it. This is much easier solution than all of these steps. Okay? What about if I have this equation? If I have this equation, sine squared x minus 3 cosine x plus 3 equal to 0. Now in this case, I cannot, it is not like the previous problem. If I didn't have the 3, I could have solved it with the last problem, but in this case, no, it is different. So, but I still could write it in terms of just one hyperbolic function. Why? Because I learned that sine squared, what is sine squared related to the cosine? I can convert the sine squared to a cosine. Do you remember? We have known that cosine squared minus sine squared is 1. Do you remember this rule? So, what is sine squared by itself? Sine squared by itself is just cosine squared minus 1. And just remember that the cosine is a big number. Cosine is a big number. So, whenever you need to convert a cosine to a sine, you must subtract 1. You must subtract 1 from the cosine squared in order for it to be a sine squared. So, I just take this to be cosine squared minus 1. Minus 3 cosine x plus 3 equal to 0. Now this equation all the terms are in terms of cosine, in terms of just one hyperbolic function. I just rearrange it to be cosine squared x minus 3 cosine x, and that will be plus 2 equal to 0. I can factorize this equation, cosine x, that will be 2 and 1 minus. So I have two equations, cosine x equal to 2 and cosine x equal to 1. Now do you remember what is x in this case? Any equation that has cosine equal to some number. Now that number must be greater than 1. If that number is negative or less than 1, what would be the solution? It will have no solution. If I told you cosine, solve this equation, for example, solve this equation. Could I have a cosine equal to half? Less than 1? No. So this is no solution. There is no solution for this. But this case, yes, we have solution, and we have two solutions, which is plus or minus cosine inverse 2. What about this case? I will have two solutions, or one solution, or no solution?
One solution.
Yes, it will be just one solution, which is x equal to 0. We know that cosine 0 is equal to 1. We know that cosine 0 is equal to 1. Now, what if I have this case, if I have tangent, if I have sine, if I have 6 sine x minus 4 cosine x equal to 4. Now in this case, I could not write it in terms of one hyperbolic function. In this case, I just put it, or you just use the definition and put it in terms of e. I'll just put it in terms of e, just as I have made in the first problem. but in the first problem we have managed to solve it in another way, but this one we cannot solve it, we can solve it only by this way. So that will be 6 e power x minus e minus x over 2 plus minus 4 e power x plus e minus x over 2 equal to 4. I'll just multiply by 2, or maybe I just make a cancellation. This is 3, this is 2, so that will be 3 e power x minus 3 e power minus x minus 2 e power x minus 2 e minus x equal to 4. These two with each other to be e power x, and these two with each other to be minus 5 e minus x equal to 4. But this is e power minus x is just 1 over e power x, so I'll multiply by e power x both sides. So it will be e power x whole squared minus 5 equal to 4 e power x. I will take this to the other side and the equation will be like this. It will be e power x whole squared minus 4 e power x minus 5 equal to 0. Yes, this is a factorizable equation, factorizable expression. That will be e power x, and we have here 5 and 1. That will be negative and that will be plus. Now we have two, yes, we will have two possibilities, e power x equal to 5 or e power x equal to negative 1. This will give me one solution, which is x will be equal to, how do I get rid of this e? Ln, yes, it will be ln 5. This will be ln 5. What about this? Ln negative 1? Could I say ln negative 1? No. So what is that? Yes, we have no solution here. We have no solution here. Why? An exponential is never negative. An exponential is never negative. Okay? It is always positive. So in that case, we have only one solution. What is the whole solution set? It is ln 5. It is ln 5.
Doctor, can I go to the bathroom?
بس انا قصدي دقيقتين هنخلص خلاص. بعد. We have learned, if I tell you simplify tanh of sine inverse x. We have learned this before, just we'll solve it again. Alpha is sine inverse x, so sine alpha is x. We make the fake triangle alpha. This is x over 1. So I complete the triangle, it will be yes, 1 plus x squared, yes. So if I need tanh alpha, it will be, tanh alpha will just be x over root 1 plus x squared. Okay, now remember even for the trigonometric, in the calculator, for example, you can find, if you make shift sine or shift cosine, we have sine inverse and cosine inverse and tan inverse, but we don't have sec inverse in the calculator. We don't have sec inverse, we don't have cosec inverse, we don't have cotan inverse. What if I needed to calculate this sec inverse of 2? How would I calculate it? How would I calculate sec inverse of 2? If you need to calculate sec inverse of 2, you need to remember this rule. Sec inverse of 2 is just the cosine inverse of half. So the rule, remember, it is not 1 over cosine inverse to no. It is cosine inverse of the reciprocal. Okay? Now remember, I will just ask you this question. Is tan inverse equal to sine inverse over cosine inverse or not? This is a very wrong expression. You cannot take the trigonometric relations and just put an inverse on them. No. Okay? So you don't ever do that. If I needed cosec inverse of root 2, how would I calculate it? If you understood what I have said? Yes, it is sine inverse of 1 over root 2. Yes, correct. That's exactly what happens for the hyperbolic. If I needed, for example, to find cotangent inverse of 3, for example. What is cotangent inverse of 3? It is tangent inverse of 1 over 3. It's very easy. If I need to find sech inverse of half, it will be cosine inverse of 2, and so on. Okay. Now, just a note. As the sine and cosine and tangent are written in terms of e, we also have, this is e power x minus e minus x over 2, and so is this e power x plus e minus x over 2, and so on. Okay, the hyperbolic functions are written in terms of e. The inverse hyperbolic functions can be written as the inverse of the e. What is the inverse of the e? It is ln. Yes. So we can write, as you could have written the sine and cosine, the hyperbolic functions, in terms of e. So I could write the inverse hyperbolic functions in terms of ln. So that's why you have expressions like these. Sine inverse x is just ln x plus root 1 plus x squared. And this is ln x plus root x squared minus 1. And this is half ln 1 plus x over 1 minus x. You need not to memorize these. If you need one of them, it will be given to you as a hint in the exam. But you need to know that there are expressions that relate the inverse hyperbolic with the ln. Okay? You need to know that you have these expressions which relate the inverse hyperbolic functions with the ln. Okay? Okay, this is enough for today.